So I'm calling in from Colorado State University, where I'm the project manager for a project that we're going to be talking about today, in which we do a bunch of diversified outreach that is novel and exciting and engaging with producers. So we'll start off by quickly providing just a bit of context about where we're talking from. So the Ogallala Aquifer region is an extremely important region agriculturally. 30% of U.S. crops and livestock are produced here. So with agriculture being the main economic driver for communities, a lot of this is actually really quite dependent on water. So while there's a range of crop and livestock production that involves grassland, dry land, limited irrigation, and fully irrigated production, it's the irrigated and ag and livestock sector that are really drawing in the greatest number of dollars. The context for this production is that the Ogallala is considered to be more or less a finite resource. The depletions of this groundwater resource greatly exceed the recharge that occurs in the region through precipitation. There are also important water quality issues that producers are faced with. So as they're managing these challenges directly or anticipating them coming down the line either in the next 10, 20 years or for future generations, there's a sincere question that we're trying to look at. A lot of people are working in the space about what's the pathway forward to find successful ways of boosting management practices and also adoption of technologies that could actually help people become both more water use efficient and maintain their productivity while also increasing or maintaining their return on investment. So the three panelists that are going to be talking today about programs they're involved with are all collaborators on a USDA-funded coordinated agriculture project called the Ogallala Water Cap. This project involves 40 researchers plus another 30-odd postdocs and students in 6 states at 9 institutions across the Ogallala region, and a collaborative, cross-disciplinary, and cross-state research effort that also has a very heavy emphasis on doing diversified outreach. So like a lot of CAPs, our diversified outreach looks at a lot of things that are pretty standard and typical. We use websites, social media, a bunch of other digital resources and print resources, and the range of field walks and field days, conferences, and train the trainers workshops. But we really are trying to put a lot of effort in our project on really figuring out, well, there's all these great ways of reaching out, but which ones are the most effective? And are there things that are happening in different states that might also be equally effective or incite or incentivize new engagement if they were transplanted to other states? So we're looking for those kinds of opportunities as well. One area in which the 3 speakers who are going to talk today about their unique programs, which are highly different, they all actually share a synergistic approach in which they're looking at how to leverage the expertise of producers, the tech companies, and academics, each in their own best way, working together to find and boosting producer exposure to these new technologies that have been validated by academic research. And so in this way, they provide low risk yet high value experiences, either whether it's on farm or through research field sites. And they're sharing university data from testing or validating these new technologies and practices along the way. So what we're going to do today is propose to take you on an Ogallala-wide tour going from south to north on a gradient. We'll start in Texas, in the Southern High Plains, where Chuck West from Texas Tech University will describe the approach of the Texas Alliance for Water Conservation. From there, we're going to head up onto Kansas, where Jonathan Aguilar from K-State will talk with us about the water technology farms, and then we'll cap it off up in Nebraska, where Darren Rudnick will tell us about the inaugural season of the new Testing Ag Performance Solutions program that's being run out of UNL's West Central Research and Extension Center. And so with that, I'll hand it over to Chuck.
Okay, folks, hello. Chuck West here, speaking from Lubbock, Texas. I'll be speaking to you about the Texas Alliance for Water Conservation, and this will be about how we go about boosting producer learning, information exchange, and adoption of water use efficient technologies. And
Chuck, we appear to have lost your audio.
Okay, this map here, and you can hear it now, I presume.
Yep, we're good.
This map here shows the changes in potential evapotranspiration across the country. Right in the middle, of course, is this high plains area where our project is taking place. This is the power of the atmosphere to suck water out of the soil and the crops. This is what drives then the ability of irrigation to make up the difference between rainfall and what the crops need. So our three areas, we have Lubbock, Garden City, and North Platte, as Amy mentioned, you represent here. But notice that there's a strong gradient. Down in Texas, we have very high rates of potential evapotranspiration and lower as you go further north. Here's this famous map again of the Ogallala aquifer. And I'm just pointing out that toward the bottom is this red circle that shows the South Plains. The South Plains then is the area where the TAWC project is concentrating. And also here on the right, we have 9 counties marked off where we have producers, about 30 farms, that we are tracking their irrigation, all the inputs, the costs and the return that they get on their production, and the yields and all that, and then we summarize those data for the benefit of the whole group. So the TAWC is a partnership with producers, a very primary part of this thing. USDA Natural Resources Conservation Service, another university here, Texas A&M Aguilar are partners there in the High Plains Water District. Our mission then is to demonstrate how to reduce water use in irrigation, and through this we are identifying profitable crop production, crop management, and irrigation systems, thanks to our contacts with the producers. And also the TAWC provides online tools for decision-making on water use and economic options. The big question facing all of us here, of course, is how do we sustain high plains agriculture? Or how do we change, how do we adapt to our changing environment to sustain agriculture? Profitability really is number one when it comes around to sustainability, because if you're not in business, you're not sustaining it. Our approach then is to stretch or push back the time at which we can no longer irrigate. The combination of those efforts then really are looking at maintaining profitability while we are decreasing water inputs, and this calls for efficiency. That's the big word here, is efficiency. We do this by demonstrating new technologies and their economics. We have, I'm just going to show a couple of different types of activities. I mentioned the producers. We are tracking about 30 farms in the area. We're now in our 13th year of data collection, and that allows us to analyze the profitability across the various cropping systems, weather variability, and market condition changes. We do field walks and field days. In those, we emphasize that the producers speak. We do have some company reps who also show us how their particular technologies work, but we are standing in the field with a producer, and that person then will tell us why did he or she choose this type of method of improving conservation. Every winter now we're putting on a water college. This is an all-day affair. It's free to anybody. We get nice big lunch. And this, we bring in some outside speakers on some specialty areas. Again, we feature producers speaking about how it works for them. In the meantime, throughout the year, we're doing fact sheets and YouTube video uploads. We have a Twitter feed and radio spots. The methods of water conservation. Now, the purpose of this talk isn't to go into the technologies themselves, what works and so on, but to tell you about what we are doing. I'm going to reflect on on several mechanisms, things that we emphasize that's used across the whole region. Irrigation scheduling, that's an extremely important tool, but it's one that the producers up until not too long ago didn't really have much access to because they didn't really know what was going on in their field. We want to move the irrigation down so that they're only irrigating at about 60 to 80% of the potential evapotranspiration. There have been some really good advances in the past 10 years or so on new crop-tolerant varieties. How do those new varieties fit into our irrigation systems? That's something else which we talk about in our field days. Newer irrigation technologies. I'll be mentioning pretty soon the LIPA, the drip systems, variable rate irrigation. This is perhaps the newest one that is really very challenging, but one that offers great prospects of improving conservation. Monitoring soil moisture, plant stress with sensors. How do we use the sensors? How do we make it pay? Adoption of other conservation practices such as staggering the planting dates, minimum tillage, improving rain capture and retention. And I want to emphasize this is very important as you move closer and closer toward dryland agriculture. And how do we decide which of the smaller areas are we going to irrigate? Where do we allocate our resources most effectively? And this slide just shows that we have various types of irrigation methods being used out there. And our field walk, for example, would be at this person's farm, where we're showing the system. Grain, sorghum, corn, and cotton. This is treated as a cropping system, not a single crop, but a cropping system. So we're looking at water use and efficiency across the whole collection of crops. This graph is one that has come out of our analysis of all of our corn-producing sites. This blue line is right on the 100 mark, indicates the point at which 100% of the potential ET or crop water demand is being met by rain and irrigation. The points to the right of the blue line indicate fields that are applying more than 100% of the water needed. So these are ones that we are focusing on to get them to move their irrigation back to a lower rate, such as 70 to 80%. This is a point beyond which there's no increasing yield. And therefore, this is where we want them to get that economic optimization. We're comparing irrigation methods, and you'll be seeing this in some of Jonathan's and Darren's talks as well. There's the LISA, low elevation spray application, LIPA, low energy precision application. Those are almost like tongue twisters, aren't they? Then there's the mobile drip irrigation. And this table here shows an example of the kind of data that we present to our producers, comparing two of those irrigation systems, LIPA and LISA, for cotton lint yield. In this case, the LIPA produced 15% higher yields. The net return per acre, more than threefold higher, dollars per acre net return. And water use efficiency, that's the WUE, water use efficiency, was again 15% greater with the LIPA system. So this tells them, this is an example of the dollars and cents analysis that we do. We do some large-scale comparisons on actual producers' farms. This is comparing like LIPA at 40 and 80 inch spacings, the mobile drip irrigation, and the LISA broadcast spray, which is more, that's an older method. And so we are analyzing those data right now. But this is where we take producers to go and look at them so they can, kick the tires and fiddle with the nozzles and ask questions to the producer how he manages that. I mentioned also that about the irrigation scheduling. This is an extremely important tool. Producers can log on to our website right here, talksolutions.org, and set up a field or do multiple fields. This will help them track the amount of water being used by the crop and how much water is coming in rain and irrigation. So they know when to apply water, how much water to apply, and how to achieve their specific management goals. Another tool we have is called the Resource Allocation Analyzer. And this is a strategic tool. This is one that they use, let's say, the winter before planting to plan where am I going to plant which crops. It matches crops to specific fields based on the well output, and it includes in there, it can capture the commodity prices and production costs to generate several options which producers can then choose to maximize their net return. We did a survey a few years ago about how they are benefiting from this, and the producers, many of them, a large majority said they benefited from their involvement in the TAWC because it helps them track their water use and soil water status. Before entering the program, they were unaware of the amounts of water applied, but now they become much more dependent on water monitoring. They've also found new technologies that sometimes they're complex and expensive, and that's why we are targeting specific technologies and crop consultants to help demystify those. Different types of decision makers. Some are going solely for profit, some are profit plus conservation, and some are the traditional ones where they really don't care about adopting new technology. Influential people. The producers look toward particular individuals in their area who are known for being innovators and early adopters, and they follow their cues. And those are the people that we put on the program to speak at these at the field walks. Crop consultants are another very important person because they have many clients. So the crop consultants can actually amplify our message to the individual clients. With that, I want to acknowledge the producers and other scientists involved in TAWC, the Texas Water Development Board, which has funded most of this work, and our collaborators with the USDA agencies. So with that, I will turn it on to the next speaker, which is Jonathan.
Okay, audio check. So this is Jonathan Aguilar, and I'm going to share with you the Kansas version of the TAWC, which is what we call the Water Technology Fund. It's a little bit different, but I would like to share with you also the things that are going on in our area. So my name again is Jonathan Aguilar. I'm an Extension Water Resource Engineer based in Garden City. So our story started because essentially the farmers asked. So every year we try to invite several producers in our area, key producers in our area, and people that are involved in crop production, and we ask them, what is it that you would like us to do in the research? And it was in the 2015 that we got a big response from these producers, and that was also the time that they have launched the mobile drip irrigation in the market, and they were really anxious about this particular technology. And so they were asking, so is this new technology really efficient than our nozzles that we are using? Or do we get more yield? What well capacity should we be looking at? So these are the questions that we got, and he said, well, stop, and we don't know the answers for these questions because the technology is relatively new. It's just out in the market for less than a year, and we don't really have any setup right now. And so, but we are willing to answer those questions from you. So from that, we took those questions from the farmers and we proposed to partners, and actually the partners responded. Why? Because it was real questions from the producers, real issues that they would like to be answered by a university at that. So we look at the mobile drip irrigation. In less than a year, we were able to set up something in our field, and we were able to do something in the field. In the next, and we were able to set up some of this mobile drip irrigation out there. So it's relatively new, but the main feature that the mobile drip irrigation is different from the others is that it has compensating emitters. It has some of these drop downs. It could be used where there's spray, and you could apply some of this fertigation or any chemicals on the leaf. And the idea here is that if you look for the next slides here, the idea here is to be able to really put those hoses down and be able to apply that water on the soil with a theory that you are not going to have a lot of evaporation, canopy and soil evaporation. So if we look at this at the next slide, the amount of water that is really going up, and this is the blue, the cooler part of the thermal image, is that those are the cooler areas where water is really applied in the field. But if you look on the right side, there's only one spot there. So the soil evaporation is really relatively low. And in fact, we were able to document about 27% in difference between a spray and a mobile drip irrigation, which is very significant, particularly if your canopy hasn't closed yet. So that is significant. But if once the canopy closed, those soil evaporation are almost negligible when you are talking about row crops in our area. So we tried it. We look at the yields, and on the next slides here, we have several of our setup from 600 gallons per minute to 150, and we've got different samples here from drip with a 2 gallons per minute emitter, 1 gallon bubbler spray, and we also look at all of those numbers. And the only significant number here is on the spray at the very low well capacity, wherein we got a significant difference. But what does this say? All this say is that if you are still in spray and if you're already on the very low gallonage, then you are not going to benefit from this particular technology. So essentially, that's all that so far that we have shown in this particular study. But we've got a lot of other results on this one. But it's interesting to see that although we do see some positive about it, there are some challenges. In order to maximize the benefits of this particular technology, it has to stay on the ground. And with doing that, you have to almost plant in circles, but it's not always the case. So even though we are planting it in circles, it's not still staying on the ground. So we are not yet able to maximize all of the benefits. Other than these challenges, we also see some of the advantages. For example, we saw a significantly drier wheel tracks in the MDI plots compared with those with the spray. And so we try to communicate with the producers that if you're using this, this is probably something that you could consider if you've got some wheel track issues. And so this is what we've got in our field. So while our story was being written on the research side, another story was also being drafted. And so we call it the Water Tech Farm, not the WTF, because it doesn't really sound very good at the first glance of it, but we call it the Water Tech Farm. What is it? So during those time, in 2015, the Kansas Water Office was also going around trying to craft a vision, a long-term vision for the future of the water supply in Kansas. And what they've been getting from the feedback from the producers themselves is that they would like to have something that is local. And so they put this in their mission. So this is the vision, and if you look at the mission of this particular document, you would see that in the vision, in the mission, it says that it has to be locally driven solutions that would allow for greater flexibility of management of the water resource. And that's what I would like to emphasize here, is that what they came out from this particular exercise is that the producers would like something local solutions. And so if you look at this issue, so how do you solve a statewide issue and have a local solution? So the concept that we got here, so that's difficult because every local conditions are different. If you look at this particular slide, you could see on the top side, on the top left, you would see all of those groundwater management districts, and on each of these other slides, or each of all of these other maps, you would see different scenarios. For example, different water table, different thickness of the saturation, different lifespan of the aquifer, and different depth to water. So all of these are different in terms of local disease. So how do you make a solution for a state that has a lot of different conditions? So the concept that we try to address this one is the concept of the water technology farms, and this is essentially how we could associate it. So each producers have their own blindness, and what are these blindness? So some of this blindness could be the lithology of where they are. It could be also the hydrology of where they are. It could also be the philosophy that they are looking at. So each of these issues that the producers are dealing about makes it complex to make a unified decision all throughout the state. So we thought that this water technology farms could be an answer, could be a step forward to trying to address all of these issues. So in 2016, a year after we set up our plots, there were 3 farmers that stepped up and would like to open up their farms to this concept of water technology farms. They do have different concerns, they do have different objectives, and they would like to do it on their own farm, hoping that they would be able to talk to their producers or to talk to their neighbors and follow also the other things that they're doing. So TNO farm, Road farm, and ILS farm all around the western part of the state. And if we look at the next slide here, we will see that each of these farms have their own objectives or concerns. For example, the TNO farm was concerned about water conservation. Rose was not concerned about that. It's more about effectiveness. And the way that he is also dealing with his farm, he's got an access to surface and well water. The ILS farm was more on efficiency. He would like to make sure that he's still efficient in whatever he does in the field. So these are some of the farms that we were able to set up in 2016. So the next year, so if those of you that haven't seen any of this type of system, I just here some of the samples of it, the bubbler, the IWAP, and each of these particular applicators are being installed in each of these fans. And so you could see here that each of these fans has a little bit kind of applicators. So moving on, in 2017, the idea caught up. And so we've got additional water technology farms signed up. And each of these technology farms, again, have different focus in the 2017. So we call these farms as the Hatchers Farm, the Circle C Farm, and we even got the involvement of the community college in these water technology farms for workforce development. And if you could see again, the next slides will show you some of the objectives of this new farms. Scheduling is more of the Hatchers. Circle C was looking at cover crops. If there is some way that they could use the cover crops in their management of the water. As I mentioned a while ago, that the community college was more on the workforce development, trying to train some of the college students to install some of the technology in cooperative farms. So that's how we set it up for the 2017. So moving on, the framework of this farm, the water technology farm, allowed public and private partnership in the Ogallala aquifer. And we've got a lot of partners that are going on in this particular project. So what has been the role of the university? So our role as a university has been to help design the farm in order to address the objectives or the concerns of the producers. There might be farms that have half field wherein one is being applied with something, with palm, and the other is not. It could be a ring test within the field, wherein some are planted in circles and some are planted in straight planting. So those are some of our roles that came up with this particular project. Some other roles that we have been doing is to provide technical assistance and monitoring activities within the farm. So we are there in their farm almost the season long, trying to monitor first and foremost the water that is being applied on the field, both on the top and below the ground. So soil moisture measuring. The other roles that we have tackled was to organize field days and other educational activities. We have opened up their fields. These farms have been opened up for field days and for producers to physically walk in the field and look at these technologies. We only prepare about an hour-long program, but the producers stay there for almost 2 more hours because they ask each other about all of these technologies. So other than that, we also try to compile the data and try to synthesize the public dissemination. Others, we try to be helpful also in public outreach. We have been getting some publicity here through the media, and I did not realize that I will be in some of the video of this project. So, in general, the impact that we were able to get from this technology farms is that it was able to showcase the technologies in the neighborhood at the farmer scales. It's a step forward from our plots. And these field days were able to foster good conversations among producers. And we were also able to identify advantages and challenges among these technologies. So I'd just like to acknowledge before I give all of the partners that are involved here, including the Ogallala Water Organization. And there's a lot more to list over here. Thank you very much for your attention.
I just want to remind everyone that if you have any questions, please put them in the chat box and we'll answer them at the end of the session. It looks like we need to switch speakers. Andy, you there? There we go.
Darren, remember to press talk.
Yep, I just wasn't sure if I was going to be controlling the mouse.
Yep,
but yes, my name Darren Rudnick. I'm an irrigation specialist here at the University of Nebraska-Lincoln, and I'm stationed at the West Central Research and Extension Center. And it's a pleasure to be here on behalf of the co-authors and the co-developers of a new program to really talk about something that we're doing, what we feel is really innovative here at the University of Nebraska-Lincoln, and that is a program that we call TAPS, Testing Egg Performance Solutions. And I, again, just acknowledge the co-developers of the program, Chuck Burr, Extension Educator, Matt Stockton, Egg Economist, Rodrigo Worley, Cropping System Specialist, all here at West Central Research and Extension Center. And we developed this in partnership with the Nebraska Water Balance Alliance and their Aquamart program. So I'd like to show this slide because I really think it gives a good overview of some of the challenges that producers go through and why research and outreach is so critical. So when we start looking at decision making on water management, producers have to really account for so many different factors, ranging from soil properties, what is the climate doing, what are the current weather conditions, their crop rotation and the current growth stage, management practices such as residue, nutrient management, and then also potential restrictions, maybe a physical restriction like a low capacity well to more of a regulatory restriction. And kind of understanding all of those and accounting for all the interactions, it's tough enough if you had to do that one time. The reality is producers have to do this sometimes on a weekly and sometimes even more than a weekly basis. And every time they make that decision, they really have to start to think, is this the most economical decision, or is this, in some circumstances, the most water efficient or the best use of this water at this time? So when we start thinking of it in that perspective, we ask what kind of management practices, what kind of tools and technology and different things out there that we could be looking at that could make that decision a little bit easier. So back in the fall of 2016, Matt Stockton, the egg economist, him and I were sitting down and we were really kind of talking about some major questions related to our extension and our research components of our appointment. And we started asking questions that seem very basic. So how do we increase the adoption of what the proven best management practices as well as technology? And who should be the teacher of this information? So should we be kind of standing up here sharing information, or sometimes maybe is there a platform that would be better if we were more of a facilitator of new information? And then how do we address questions by producers in a timely fashion as compared to really addressing some of our own personal research interests? And then lastly, how do we develop something that would be able to connect with a lot as compared to a few producers? So when we were asking these questions, we kind of came up with a hypothesis, and that would be producers would be more apt to adopting technology and best management practices if they were able to try them without exposing their whole operation to unknown results. So kind of a low-risk environment, and Amy kind of touched base on that early because that kind of shares across what Chuck, Jonathan, and what we're doing in Nebraska. And the second one is really being able to evaluate how their management practices are doing against their peers, not necessarily against what the university is doing, but what are others doing, what is working and what's not working. So with that, we developed a program that really focused in on engaging the agricultural producers around two topics: resource use efficiency and farm profitability. And we wanted to do this by developing a platform that had peer-to-peer opportunities, as well as the involvement of university scientists and industry personnel. Because I feel like everybody has a very competitive nature, we felt like really to generate some discussions and get everybody motivated, a competition would be maybe the best approach. So we went ahead and developed a very systems-style farm management competition, and we coined that underneath our TAPS platform. And again, it's a platform that we can use to observe and use new ideas and technology, test conventional wisdom, and essentially try to find better ways to do business, especially when the economy is in a tough spot. One more, if you can hit that. Forward, sorry. So when we look at the description, we really, as we developed this competition, we wanted the producers to make decisions across really what they're doing on their own operation. So we had 6 that we selected this last year, or 2017, and we had them select their insurance. They had to market their grain. They had some biophysical decisions, so they had to select their nitrogen application as well as amount. So they had options of pre-nitrogen, side-dress nitrogen, and 4 options for fertigation. They had to provide their hybrid as well as the density that they wanted us to plant. And they also had to schedule their irrigations as well as select the amount that they want applied. So with this, instead of one approach would be to kind of work with producers on their own operations, but really, again, we wanted to get everybody to one location for us to really improve the communication across everybody, as well as provide an opportunity for industry to come in and be able to have producers use some new tools and methods. And then also we can provide more statistical evaluation of what's working and what's not working. The image that you have up on the screen is the field in which we actually have the competition going. So we developed it very much like an experiment. So we had 15 what we call farms, which are really teams of individuals or groups of producers. And we have 3 reps for each of the farm, and then we have that randomized in a complete block design. So because it is a competition, we have 3 awards. The first award, because we feel like this is very critical, we have it as the most economically profitable farm, and they get a $2,000 cash award. The second is highest input use efficiency, and we've come up with a really exciting metric that ties in water and nitrogen. And then the third one is highest grain yield, which we actually have a slight dock because we don't want to stress high grain yield. We actually want to stress profitability. This is a picture of our kickoff meeting back in March of 2017 and the list of the growers that are participating for this first kickoff year. So this, I think, really shows kind of how we're trying to tie everybody together around these 2 important things. One is improving input use efficiency, and the second is profitability. And we really are stressing that it's not just on the grower side to try to solve these problems. It's not on the university side, but we can all learn. We really are encouraging, and we've gotten great support from industry as well as regulatory agencies such as our Nebraska Natural Resource Districts, and also nonprofit organizations like our commodity boards and groups like the Ogallala Water Cap Project. Again, we're all coming together, opening up discussions, and we're also providing resources that could really move this forward. So this is a timeline that kind of shows how things are. We started with a kickoff meeting in March, and then we're actually ending with an awards banquet in the second week of December. So again, it's just kind of a progression of how things have developed, and we have a website called taps.unl.edu, and we put a lot of information up there, and we also like very transparent on how and what's up there, so really get a detailed view of what's happened so far, if interested. So one of the questions one concern that we had is if people go into this competition, are they going to be doing what they actually do on their own operation? And what we can see here is there was considerable differences. It's amazing to see how many different styles of management that people have. And this red box really kind of shows it. So out of the 15 farms, if we were to remove the control as well as the deficit UNL treatment, we had 11 different hybrids that were provided. We have producers that were planting from 28 to over 34,000. In terms of nitrogen management, we had 150 to 240 pounds per acre, and then irrigation from a little over 2 inches to exceeding 10 inches. The important thing here is not necessarily that there's differences, but the fact that if there are differences in management styles, that means there might be, and most likely there will be differences in solutions on how we improve profitability and resource use efficiency. And so for us being able to generate, next slide, really the data and the information for producers to really understand and evaluate their management decisions. So we've collected a great deal of information on this field with help from our sponsors and industry partners. So everything from sensing the crop, looking at the climate. So we have an eddy covariance tower by LICOR as well as a weather station from Farmer's Edge, imagery from Air Scout. We've had very great support from our one of the labs, Ward Laboratory, collecting grain and biomass. We're going to crunch all of this data and be able to provide this feedback back to the producers later this year. So one thing we have on our website, we want all of this information to be accessible by our producers, both that are competing as well as those that are not. So we have on our resources page on our website, producers can go in and they can look and get information. And we also, any data that's being collected on the field that's not specific to an individual farm, we have the logins here so people can go in and see what the imagery looks like and the data. And then we also have individual logins where people make their decisions and have access to specific data that's just for them. Next. One more. So just a couple of summary slides to get back to our hypothesis that we developed in one of our field days in August. We wanted to really try to ask those questions and see kind of how people felt about the TAPS program relative to increasing adoption of technology and best management practices. So we asked this question on whether or not they felt TAPS would improve adoption if they were able to use different equipment and styles of management without exposing their whole operation to these unknown results. And out of that, we had 72% of the respondents that said yes, 28% said maybe, and 0% said no. And then the second question would be, we were really curious on, do producers want to see how their management practices compare against their peers? And we actually had a very strong yes. 79% said yes, 18% said maybe, and 3% said no. So we have definitely got some great encouragement by the producers that are participating as well as those looking in. And we're very excited to really be able to crunch this information. Just the next slide. So when we look at how we're engaging others, we've done a lot of newsletters, a lot of field tours. We provide an opportunity like workshops for industry to come in and talk about how do you use and how do you navigate their different systems so producers can learn a little bit more about them. The Nebraska Farmer has done some excellent articles as well as our Crop Watch at UNL. So again, we try to get as much information out, and we're really now going to be crunching that data and providing that to our stakeholders and our growers in Nebraska. So with that, all of this would be wouldn't be possible without having strong support from everybody from industry, commodity groups, the natural resource districts, and especially our growers. So with that, I'm going to send it back to Amy to kind of close things up.
Again, if you have any questions, please put them in the chat box on the bottom. Amy, you there?
There we go.
Press talk. Yeah.
There we go. All right. So just a quick reminder that for our three speakers, here's their websites. If you want to follow up further, I know that Chuck, Jonathan, and Darren would be happy to take questions offline and to talk further about where they're taking these projects in the coming years. And also, we'll be tracking these projects and also pointing to them from our Ogallala Water Cap project resources. So that includes our digital newsletter, which you can sign up for at our project website, ogallalawater.org. And we're also maintaining at Colorado State University the Ag Water Conservation Clearinghouse website, which is another great place to find out about events, databases, irrigation scheduling tools, and other information pertinent to water conservation. And you can also find us through social media on Twitter and Facebook. So we hope you can follow along.
We do have a couple of questions in the chat box. I'll ask those first, and then Amy, you can ask yours after that.
Great.
Alexandra Reyes, I think she was asking Chuck West, are there any patterns on the irrigation issues? So are you seeing the same things coming up, I think, is what she's asking on the irrigation issues. And Chuck, we need to turn you on.
Yeah, so what was that again? Have there been any, what was the question again?
She asked, are there any patterns on the irrigation issues?
Any patterns?
Yeah, so I guess, are you seeing the same thing consistently with different producers?
Yeah, well, something which is interesting from this that we've learned, that even with the LISA system, which is somewhat older system, that there are things that can be done without having to go through and just change the whole operation. Irrigation scheduling goes a long way toward reducing the over-irrigation. So it's not necessarily required that a person come in and change all the nozzles and everything or convert to drip. And even with the LISA system, one can convert it fairly easily to that mobile drip irrigation. That's a lot cheaper than going through and putting in subsurface drip. One of the things that we have found, though, a big challenge that we have found, that when some of the producers have brought in a more efficient irrigation system, that they did not reduce the amount of water that they applied. Okay, even though that is one of the benefits of that new technology, and so they end up over irrigating, and maybe getting higher yields, but not necessarily higher economic yields. So those are some of the things that we have found. But there's a lot that can be done even without buying the whole new equipment.
Great. We had another one from Venki Udamari. What have been some challenges in convincing farmers to adopt conservation technologies? And I think that probably applies to all of our speakers. That's a pretty big question. Chuck, you want to take that one? We'll go down the list with Darren and Jonathan as well.
Yeah. One of the challenges that we have been somewhat struggling with lately is that, when you instigate a new program, such as a water college or a field walks, you get a great turnout for the first few years. And then things start trailing off. It sounds to, that again. So we're always looking for ways to spice it up and do some changes. And this is why I'm really enthralled about the TAPS program that I learned about up at North Platte, because there are some things that we can learn from that we can put into our program.
Great, Darren, do you want to respond to that?
Yeah. So on our part, one of the issues one of the challenges of convincing farmers is the fact that if they do some conservation on their particular farm, they would like to have their neighbors do the same thing also. Because what we are dealing here is the Ogallala aquifer, which is on the ground, and if someone sucks it out, the idea is that if you don't suck it out, the idea is that somebody will suck it out. So in some cases, we are dealing with some localized issues, and we would like to have everybody, well, the producers in particular, would like to have a shared action on that particular issue, because they think that if they do it alone, somebody else will be taking off their water. I think from my point of view, that might be one of the challenges that we're dealing with.
And Darren? And
I'll just add in a little bit, and I agree with Jonathan and Chuck. I think that some of the challenges associated with adoption of technology, I think it's some of those reasons why I think individuals just don't adopt anything, right? So sometimes it's one is obviously cost, or two, that maybe they don't fully understand, or they don't feel like they have enough time to really understand how to use it at a high level to make it worth that cost. And then sometimes maybe the support system, they feel like if they get something, they might not have enough support if something goes wrong. So a lot of these, I think, are definitely able to be overcome. It's just a matter of engaging and working with producers and building kind of those larger networks and neighborhood networks that Jonathan was talking about, and make it more of a norm rather than an outlier.
Great. Amy, did you have some other questions that you wanted to ask?
Yeah, well, I guess one question I think I would like to ask is, given the key takeaway of the importance of helping provide low-risk options that are high value and that demonstrate the value of the cost of improving cost, making the return on investment and the cost of production work out in adopting these technologies. Could you speak to kind of maybe an idea or two of where you think you're headed for next growing season?
We go down the line again with Chuck. You want to start?
Well, next we are going to be introducing a beta version of a new irrigation scheduling tool. And so with that, we are going to identify just a few producers that we are going to be working with. In other words, sort of holding their hand, because this one is going to be more sophisticated. It involves capturing satellite imagery and using some new software that's being developed here to translate that into soil water content and the crop water status. And so we're going to be trying that out next year with just a couple of select producers, and then you tweak it, and then in 2019 open that one up. Yep, that's coming up.
So on our part, the Water Technology Fund, we were fortunate this year that we were funded by the NRC CIG Conservation Innovation Grant to expand it to probably a couple more producers' field. But at the same time, we probably, as many of you probably know, that working with a producer's field, there's a lot of moving variables in that. And so just doing it almost on a yearly basis, we'll probably have some more data to be able to make some definite or more conclusive information for the producers to be able to take on.